Thomas Zero, an ex-NASA scientist and director, commented on the launch of the James Webb Space Telescope, JWST. James Webb marks the beginning of a new era in astronomy. Webb will expand and test our cosmology, our understanding of planets, and the place where life began. What began hopefully turned into a debacle. With James Webb's astonishing discoveries, scientists now face a crisis. The telescope's findings have sparked debates in physics, raising questions about old theories and whether they might be wrong. Could these discoveries bring an end, at least temporarily, to these long-standing discussions? But what exactly does this mean? Have scientists truly unraveled the mysteries surrounding James Webb's impossible discoveries? Or are we being stalled with flimsy explanations? Webb was expected to provide solutions. Instead, the $11 billion project has plunged cosmology into a major crisis. Every field of natural science associated with space is currently experiencing a shakeup, similar to the upheaval during the Middle Ages when the heliocentric view of the world replaced geocentrism. Now, we may need to acknowledge that the foundations of modern physics are flawed and that we have only scratched the surface of understanding the cosmos. How is this possible within contemporary astrophysics? In other words, the physical quantities and relationships observed in the cosmos are based on fundamental laws of physics, principles that trace back to researchers of antiquity, the Middle Ages, and specifically Sir Isaac Newton. The earliest insights into mechanics and dynamics began in antiquity, where forces and quantities were described for the first time. Later, Newton's discovery of gravity became essential for astrophysics. Our scientific observation of the universe was built on these foundations. The forces and quantities observed on Earth were assumed to apply universally, producing consistent results, until our ability to observe space expanded beyond what we had ever imagined. As our view of the universe grew, the known quantities no longer fit what we observed. This crisis began when different methods for determining the age and expansion rate of the universe produced contradictory results. Local measurements based on astronomical objects within the universe yielded different values compared to measurements of the early universe derived from cosmic microwave background radiation. This discrepancy is known as the Hubble tension. In the summer of 2022, Webb discovered numerous ancient and highly developed galaxies that cast doubt on the established age of the universe. Our cosmos, believed to be 13.8 billion years old, appears to contain galaxies that were already well-developed just 200 to 100 million years after the Big Bang. According to current physics, galaxies require billions of years to develop. If Webb's findings are accurate, some galaxies may have formed before the Big Bang itself. This contradicts the traditional cosmological model, which holds that the universe began with a Big Bang 13.8 billion years ago, has been expanding ever since, and has undergone a slow evolutionary process. We now face a crossroads. Either the physics observed on Earth cannot be applied to the entire universe, or we have only deciphered a small portion of physics as it truly exists. The ancient scholar Hermes Trismegistus once said, "As in small things, so in great things." This maxim suggests that the laws of physics governing the cosmos should also be observable on Earth. Yet perhaps we have overlooked forces and dimensions on our planet that we are now noticing in space. Webb breaks all records. It's a technological marvel. With its honeycomb-shaped mirrors, Webb can detect extremely faint light signals that have traveled for more than 13 billion years. Thanks to revolutionary exposure methods, these faint traces of light are visible for the first time, revealing galaxies that formed shortly after the Big Bang. In the summer of 2022, these discoveries were both a sensation and a disappointment. Instead of immature, newly formed galaxies, Webb captured images of perfectly developed galaxies that appear to be 13.5 to 13.6 billion years old. This should be impossible. Some scientists have suggested that the images might be flawed or misinterpreted. However, Webb can only show us the truth. Science must now admit that it has likely been on the wrong track for over a century, the approximate age of our current standard cosmological model. Webb works perfectly, yet large parts of our scientific community are still grappling with these new realities. Some traditionalists resist accepting this paradigm shift, much like the resistance encountered during the Middle Ages when the Church refused to accept that Earth was not the center of the universe, even as astronomers across Europe presented overwhelming evidence. Today, while scientists no longer face imprisonment for proposing revolutionary ideas, the conflicts and resistance to new perspectives persist. Imagine spending your entire life searching for answers, firmly believing in a particular theory, only to witness evidence that tells a different story. It's natural to rebel against such a revelation. Accepting a new truth takes time. However, many open-minded, young scientists are excited by Webb's discoveries. Rohan Naidu, who discovered the galaxy CRS 93316, and Finnan, who discovered another remarkable galaxy, represent this new generation of researchers. They approach Webb's findings with curiosity and enthusiasm, studying its images from the moment they were released. But was Hubble wrong? One of modern cosmology's greatest debates centers on the Hubble constant, the rate at which the universe is supposedly expanding. In the 1920s, astronomer Edwin Hubble observed that distant galaxies were moving away from us, concluding that the universe was expanding. Belgian astronomer Georges Lemaitre later proposed that this expansion began from a single point, the Big Bang. However, alternative methods suggest that the movement of galaxies can be explained differently, producing coherent models that were long ignored because Big Bang theory seemed more probable. Yet, the more we observe the universe, the more discrepancies emerge. This issue didn't start with Webb. Years ago, astronomers noticed regions of space where expansion behaved differently, sometimes faster or slower, denser or emptier. This led to speculation that the universe may have multiple starting points or that it is continuously fed by multiple sources, which may not have begun simultaneously. Once again, alternative theories about the universe's nature, age, and shape have surfaced. Yet, researchers have clung to the Big Bang model and the idea of expansion. Perhaps this was a mistake. As we've seen with the Hubble tension, distance measurements in the universe vary depending on which fixed points are used as constants. Scientists now believe that Webb, throughout its mission, will help resolve this tension by precisely measuring galaxy distances and redshifts. Not only could this correct errors in previous measurement methods, but it could also mark a turning point that ushers in a transformative paradigm shift in cosmology. These developments present both challenges and opportunities for modern science. On one hand, the unexpected discoveries force scientists to question long-standing theories, while on the other, they offer a unique chance to advance human knowledge in ways previously thought impossible. This moment in history mirrors past scientific revolutions, where breakthroughs initially met with skepticism eventually led to profound paradigm shifts. The data from Webb suggests that the universe's early structure and development do not align with current cosmological models. Traditional theories, including the Big Bang, rely on the assumption that galaxies formed gradually over billions of years. However, Webb's observations of fully developed galaxies appearing shortly after the Big Bang challenge this assumption. If galaxies formed more rapidly than previously believed, it could mean that our understanding of cosmic evolution is incomplete or fundamentally flawed. Moreover, the discovery of galaxies that seemingly predate the Big Bang raises even more profound questions. How could such galaxies exist before the event that supposedly created the universe? Some scientists propose that the Big Bang may not have been the absolute beginning of everything, but rather a transitional phase within a larger, cyclical process. Others suggest that multiple universes may coexist within a multiverse, each governed by its own set of physical laws. These possibilities, while speculative, highlight the need for a broader perspective in scientific inquiry. Clinging to established theories simply because they have been widely accepted for decades may limit our ability to understand the universe's true nature. Just as Galileo's heliocentric model eventually replaced the geocentric view, today's scientific community must remain open to revising or even abandoning current models if new evidence demands it. At the same time, it's essential to approach these discoveries with scientific rigor. While Webb's observations are groundbreaking, further research and verification are needed to ensure their accuracy. The telescope's advanced instruments are capable of detecting extremely faint light from distant galaxies, but interpreting these signals correctly requires careful analysis. Misinterpretations could lead to false conclusions, so scientists must scrutinize every detail before reshaping fundamental theories. Additionally, the implications of Webb's findings extend beyond astronomy and cosmology. They challenge the foundations of physics itself, raising questions about the universality of physical laws. For centuries, scientists have assumed that the laws of physics observed on Earth apply uniformly throughout the cosmos. However, if distant galaxies behave in ways that defy these laws, it could indicate that our understanding of physics is incomplete. Forces and phenomena unknown to modern science may play a role in shaping the universe, opening the door to entirely new branches of physics. This shift in perspective could lead to practical advancements in technology and space exploration. A deeper understanding of cosmic forces might enable humanity to develop new propulsion systems, harness energy from previously untapped sources, and explore distant regions of space more efficiently. Just as Newton's laws of motion paved the way for modern engineering, future breakthroughs in physics could revolutionize our ability to navigate and utilize the cosmos. Furthermore, Webb's discoveries may have philosophical and existential implications. For centuries, humans have sought to understand their place in the universe, often framing their existence within the context of a finite cosmos with a clear beginning and end. If the universe is older, more complex, or more interconnected than previously believed, it could reshape our understanding of humanity's role in the grand scheme of existence. The possibility of a multiverse, for example, raises profound questions about the nature of reality and the potential for other forms of life beyond our own universe. Despite the challenges and uncertainties, the scientific community stands at the threshold of a new era. Just as the advent of the telescope transformed astronomy in the 17th century, the James Webb Space Telescope is poised to redefine our understanding of the cosmos in the 21st century. Its discoveries, while unsettling to some, represent an opportunity to push the boundaries of human knowledge and unlock the secrets of the universe. Ultimately, the scientific process thrives on uncertainty and discovery. Every challenge to established theories brings us closer to the truth, even if it requires letting go of long-held assumptions. As scientists continue to analyze Webb's data and refine their models, they may uncover answers to questions that have puzzled humanity for centuries. In doing so, they will not only expand our understanding of the cosmos, but also pave the way for future generations to explore and appreciate the universe in all its complexity and wonder. As the journey continues, one thing is certain. The James Webb Space Telescope has opened a new chapter in the story of human exploration, a chapter that promises to reshape our understanding of the universe and our place within it for generations to come. Propelling us into a new epoch of advanced physics that seeps into the very foundation of monumental to cosmic reality. This achievement stands as a testament to the unwavering zeal and perseverance of generations of researchers who have devoted their lives to unraveling the enigmatic mysteries of the universe, tirelessly pushing the boundaries of human knowledge ever further in their search for truth and understanding. In their relentless pursuit of knowledge, these intrepid explorers have not only expanded the horizons of our understanding of the cosmos, but they have also improved our collective consciousness, igniting a sense of wonder and awe at the vastness and intricacy of the cosmos that surrounds us. As we stand at the precipice of this new frontier, poised on the threshold of discovery, it is our responsibility to approach each new revelation with open minds and open hearts, ready to embrace even the most unfamiliar or shocking findings that may reshape our understanding of the universe in unexpected and profound ways. Indeed, The emergence of new theories and alternative explanations heralds the dawn of a new era in scientific inquiry, where established theories face new challenges and daring concepts beckon us into previously unknown realms of expertise and investigation. At this pivotal juncture in history, we find ourselves on the cusp of a profound scientific revolution, where the investigation of the universe's oldest points of light holds the enticing promise of revealing the deepest truths about the nature of existence itself. With the aid of cutting-edge technologies such as the James Webb Space Telescope, we are prepared to embark on an extraordinary journey of discovery, delving ever deeper into the cosmic tapestry to unravel the mysteries of accretion disks, probe the enigmatic realms of supermassive black holes, and peel back the layers of cosmic phenomena that shape the very fabric of our universe. But as we plot this daring course into the unknown, we must also be cautious and mindful of the complexities and uncertainties that lie ahead. For every new revelation brings with it a host of new questions and challenges, inviting us to venture further into the abyss of the unknown and confront the mysteries that have remained unseen throughout the vast tapestry of cosmic evolution. Each new discovery is a thread woven into the intricate fabric of human knowledge, enriching our understanding of the universe and our place within it. As we begin this exhilarating journey of discovery, let us not only celebrate the triumphs of science, but also embrace the uncertainties and challenges that lie ahead. For it is through adversity that we grow and evolve, both as individuals and as a species, forging a path toward a brighter and more enlightened future for all of humanity. We would then have to examine our cosmology once more and discover whether black holes played a much more significant role in the evolution of the universe than previously thought. One theory pointing in this direction comes from the British scientist Roger Penrose, who believes that the universe is constantly recreating itself in cycles, and that, in some way, black holes could endure such transitions as gigantic stores of information. Penrose proposed this theory long before Webb was launched. Although he is a renowned researcher, his work was not widely accepted, yet that is now changing. Webb's mission has only recently begun. Yet we already have a second deep image revealing the discovery of a very old, extremely large structure that does not fit into the expected timeline of the young universe. This growing body of evidence, found in the vast expanse of the cosmos, where galaxies swirl and stars dance in a cosmic ballet, marks the beginning of an adventure of discovery unlike any other, thanks to the launch of the James Webb Space Telescope. As we stand on the precipice of a new era in astronomy, the anticipation of what Webb will reveal fills us with excitement and wonder. It is not merely a tool for peering into the depths of the young universe. It is a beacon of exploration, tirelessly charting the celestial landscape, unveiling the secrets of distant worlds, and providing insights into the mysteries that have captivated human imagination for centuries. The scope of Webb's mission extends far beyond our own solar system. With its unparalleled capabilities, it delves into the realms of exoplanets, probing the atmospheres of alien worlds and searching for signs of habitability, offering tantalizing glimpses into the possibility of life beyond our own blue planet. Webb's keen eye is also turned inward, illuminating the complexities of our solar system, from Mars' rocky terrain to the icy moons of Jupiter, with unprecedented detail and clarity. But Webb's reach extends even further, stretching across the vast expanse of space to capture the splendor of the most massive and beautiful structures in the universe. From the swirling arms of distant galaxies to the luminous glow of nebulae, each image captured by Webb tells a story of cosmic evolution, of stars being born, galaxies colliding, and a cosmic dance that has unfolded for billions of years. Yet, Webb is not merely a passive observer. It is a catalyst that propels us forward in our quest to unlock the secrets of the universe. With each observation, another piece is added to the cosmic puzzle, enriching our understanding of the fundamental forces that govern the cosmos. Even data collected from seemingly distant realms holds the potential to offer invaluable insights into the structure of the universe, providing clues about the nature of dark matter, the origins of cosmic rays, and the fundamental laws that govern the behavior of matter and energy on the largest scales. In our pursuit of knowledge, we are driven by a desire to uncover the underlying framework that governs the cosmos, a cosmic matrix that holds the key to understanding the universe in all its complexity. Webb's revolutionary capabilities propel us forward in this quest, opening new perspectives and sparking fervent debates among scholars as we grapple with the repercussions of its findings. Though we may find ourselves amidst a period of uncertainty and heated discourse, we remain steadfast in our belief that this intellectual crucible will ultimately propel us closer to the truth. So, as we eagerly await the next revelations uncovered by Webb, let's embrace this journey with optimism and curiosity, knowing that with each new discovery, we inch closer to unlocking the secrets of the cosmos. And to stay updated on this thrilling expedition of discovery, don't forget to click the subscribe button. Many more captivating videos are sure to follow, each offering a glimpse into the wondrous mysteries of our universe and the groundbreaking discoveries that await us.